Hi everyone, welcome to trigonometry. Today we explore lesson 19, polar coordinates and polar equations. Number 1, polar coordinates. Let's take a look at the XY plane and we're gonna sketch a circle where the center of the circle is that origin. So if we pick a point on the circle, then that point is XY. X, this Y. The point XY is in rectangular coordinate. We can also get to the same point XY using the radius R. That's R and the angle theta. The point R theta is an equivalent point in polar coordinate. So given the point XY, how to convert it to polar coordinate? Well, notice that there's a right triangle right here. So R squared is X squared plus Y squared. That tells us that R is root X squared plus Y squared. And we can also see a relation between the angle theta X and Y. Tangent of the angle theta is Y over X. So the angle theta is arctangent of Y over X. And make sure that the angle theta has to be the exact angle in the quadrant that the point lie in. Must be in quadrant of the point XY. Second question, given the point R theta, how to convert it to rectangular coordinates? Well, we see that the sine of the angle theta is Y over R. Tell us that Y is R sine theta. Cosine of theta is X over R. Tell us that X is R cosine theta. Oh, pretty cool. Let's do some example. First example, convert the point 2, -2 root 3 to polar coordinate. Let's sketch up. It's X, that's Y. This 2, -2 root 3 is the point right here. The polar coordinate gonna have a radius R and an angle theta. Radius R is root of X squared plus Y squared, so that is root of 2 squared plus -2 root 3 squared. That is 4. The angle theta is arctangent of Y over X, which is arctangent of -2 root 3 over 2 and arctangent of -root 3 is, well, in the calculator that gives us the -0.3 because the angle lie in the fourth quadrant and the angle is positive. We're gonna add 2 pi. Theta is positive and theta is in quadrant 4. And this gives us the angle theta to be 5 pi over 3. So we have the angle theta and the radius. Another example, convert -1, to polar coordinate. X, Y. -1 minus 1, 1. So it's the radius. That is the angle theta. The radius is root of x squared plus y squared, which is root of -1 squared plus 1 squared root 2. The angle theta is arctangent y over x, and that is arctangent of 1 over -1. In the calculator, it gives us -pi over 4. The angles in the second quadrant, so we need to add pi. Theta is positive. Theta is in Q2. And so the angle theta is 3 pi over 4. Let's move to 2. Polar equation. It is very important that we know how to sketch this equation. A r equal 2. So r is the radius, and it equal to mean that for every angle theta, the radius is 2. So 2 from the center. And when we connect them, we get a nice circle of radius 2. B theta equal pi over 4. For every radius, the angle is pi over 4. The angle is pi over 4. Connect a line through this point, and you see that, oh, this is just half of a straight line. Yeah. What about r equal to sine theta? This is a nice polar equation, and it is also called the polar equation in the form r equal f of theta. To do this, we need to plot the point. So method 1, plot points. We have a r equal f theta. So theta r, when theta is equal to 0, radius is 0. When theta is pi over 6, sine pi over 6 is half. 2 times a half is 1. When theta is pi over 4, sine pi over 4 is root 2. Root 2 times 2 is root 2. Sine pi over 3 is root 3 of 2 times 2 is root 3. Sine pi over 2 is 1. 1 times 2 is 2. And we have a 2 pi over 3. Well, this gives us root 3. 3 pi over 4. Which gives us root 2. 5 pi over 6. That's 1 pi, which is 0. Yay. Let's take a look at the plot here, see what we have. X, Y. We go from 0 back to 0. Sine of 0 is 0. Sine of pi over 6 is 1. And then it get a little bit bigger. Pi over 6. Pi over 4. Pi over 3. And pi over 2. The other side just a reflection. Gonna connect this point and then we're gonna get a reflection. Oh, look at this. It does look like a half circle, right? Or semicircle. And on the other side, we're gonna get another semicircle. So when we connect them together, what we have here is a circle of, this is the center of the circle, radius 1, center at 0, 1. Wow. There has to be another way to see this circle. Method 2. Convert to rectangular equation. Okay. R equal to sine theta. We know that sine of the angle theta is y over r. So r is 2 times y over r. Multiply both sides by r. And this gets us r squared 2y. Now we're going to do the substitution. R squared x squared plus y squared equal 2y. Move everything to one side. So we have x squared plus y squared minus 2y equal to 0. And then from there, we're going to complete the square. X squared plus y squared minus 2y plus b over 2 squared. So it's negative 2 over 2 squared. Do the same thing to the other side. 0 plus minus 2 over 2 squared. We have x squared. And this we're going to factor. Well, the factor is y minus 1 squared. And we get 1. So that is right. Yeah. If you look up this is the equation of the circle that has the radius of 1, center at 0, 1. 3. Convert rectangular equation to polar equation. A. X minus 2 square plus y square equals 4. To do the conversion, first thing that we have to do is FOIL out the x minus 2 square. So x minus 2 square is x square minus 4x plus 4 plus y square equals 4. Here we have x square plus y square equal. Gonna add the 4x minus 4 to the side. So we have 4x. X square plus y square is r square. X is r cosine theta. Divide both sides by r and we have a r is equal to 4 cosine theta. Pretty cool. In B, x square minus y square equal 1. Oh, it's a little tricky. Well, we know x is r cosine theta, so let's do the substitution for that one. R cosine theta square minus y is r sine theta square, and that's equal 1. R square cosine square theta minus r square sine square theta equal 1. We can factor out the r square, and we have cosine square theta minus sine square theta, that is 1. Cosine square minus sine square is cosine 2 theta. Oh, double angle formula, r square. So this tells us that r square is 1 over cosine 2 theta. And r square is 1 over cosine is secant. So secant 2 theta. The radius is always positive, so we can square root both sides to give us r equal to root of secant 2 theta. We know x square minus y square equal 1. It is a hyperbola. Let's sketch both of them on decimals to confirm that we get the correct answer. Okay, the first graph is x square minus y square equal 1. Yay, a hyperbola. Second one is r equal to square root of secant 2 theta. Oh, it's the same thing. So that's why you see that it coincides. This is the same graph here. Oh, pretty cool. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. See you in the next video.